Ready to start this session. Thank you very much for staying back. For those that are here, we're going to bring some popcorn now. No, I'm just kidding. So I want to start this session by telling everybody that we've got a stellar group here. I will let everyone introduce who has not introduced himself. And we're going to go into topics specifically in the healthcare and quantum computing and the impact of where quantum will be in the future and where we now and how to project that in the future. Starting with the ladies here, I'm going to present not only a good friend, my partner, Dr. Libia Scheller, who we consider a futurist, and you'll quickly know why. And Libia, why don't you start with the introductions about yourself? Here you
Sure. Is this working?
It's all working differently.
Hello, everyone. It's so good that you came for this topic. So I'm originally from Colombia, and I've been in this country being educated and in Europe. And my background is I have an undergraduate degree in genetics. I love DNA. DNA is where it's at, I thought, instead of working with machines. So I have a degree in genetics. I have a PhD in immunology. I have a postdoc in vaccine development, and I did a year in the Amazon working with the Yanomami Indians and trying to solve problems of health in the middle of the jungle. So anyway, I have been in the area of therapeutics. I've been making, when immunology merged with oncology, I became an immuno-oncologist, and I've been developing drugs for cancer for many years. I also had my own education company in the area of, I taught oncologists immunology and technology and the future where we're going. And then after being 25 years in the pharmaceutical industry, I decided, like, what am I really doing here? Am I curing anybody at stage 4 cancer? No. So I started thinking about what can we do with computers that can help us diagnose earlier. So I started Miami AI Ventures. I've been in Miami for 23 years, but I've been in global. I started Miami AI Ventures. Now, Miami does not stand for Miami, Florida. What it stands for is Masters of Innovation, Acceleration, Monetization, and Investments. And along with that, along with our partners, what it is a conglomeration of many companies all working together to support startups from the beginning to the end, everything, including everything support business development and also access to finance, to capital. Also with Henryk and my other partner, Dynamo, we started a health tech fund. $50 million fund. We invest in healthcare, health tech, anything to do with diagnostics, anything that's going to help us understand where we are today. This all falls under the same bridge of longevity medicine. So that's where I'm doing now. I'm hanging up the hat. I'm getting away from making therapeutics. I don't think that's where it's at. If we want to cure diseases, you know, everybody's talking about drug design. If they only spent their time in diagnostics, we'd be better off. Anyway, that's my background.
Thank you, Dr. Scheller. As always, very impressive. Victor, as the two gentlemen before you have already introduced themselves, I'm going to leave it to you. Please go ahead.
Hello again, I'm Victor Karamalis, co-founder of Ladder Studio Labs, where we're trying to make proprietary materials at a fraction of the cost of traditional R&D pipelines. I'm very impressed with Dr. Scheller, by the way. I have a master's from NYU. I did my thesis work under the Global Business Technology Director at Pfizer. Where I focused on healthcare, privacy and security, including during clinical trials. I was a research scientist at Fordham University, where I was working in conjunction with Fordham University and University of Utah and at Los Alamos National Labs, where we were creating the largest repository, or the most comprehensive repository of liquid extraction reactions to basically extract F element metals, which are basically radioactive elements, and recycling them. So that's kind of what my background is right now.
Thank you very
Very
much.
cool.
So I have to wear my healthcare cap on this time. So I want to just give context as to, so you don't think, what the heck is Nardo doing there? So my background prior to starting a quantum fund, I actually have 30 years plus of healthcare technology background. I was a former, I used to run Kaiser Permanente Step Fund. I invested in 65 companies there. I scaled 12 companies on a national level. From a corporate venture standpoint, investing in anywhere from 10 to 30 mil on that level. And one of my most favorite things to do is sunsetting legacy systems. So, so from a statistical standpoint, we 65 companies invested in 12 national scaled nationally, 189 systems deprecated, okay, or sunsetted. And I'm either the most favorite guy or the most hated guy in healthcare, mainly because of the change that I made there. And then after that, I basically created a venture studio for healthcare, where I helped 36 companies, raised 395 million for those, and generated 2 unicorns and 9 failed companies today, and the rest are just moseying along. So I'm here to participate in that capacity as opposed to the other capacity.
Thank you very much. I think that, as I told you, we have a stellar team today, and a lot of knowledge and sitting here. I'm going to start with a general question because I think that healthcare and quantum computing still have a big question mark. And my first question to the panel is, why don't we speak about where we're coming from and why do we think quantum will be the future? I would like Dr. Scheller to start.
Thank you. So I just want to who's in the health field here? We have a couple. Okay, good. Hey, look who's here. Okay. Where we've been has been very interesting. Where we've been, it's all comers. Like you go to the doctor, they give you a medicine. They don't discriminate as to who gets that drug, right? And it works for some people and it doesn't work for others. So in the past, we had drugs that caused very high toxicities. We had drugs that were really not curing anybody. And we did kill a lot of people in clinical trials that way. So in the past, it was very slow to make any kind of drugs for diseases. Just to give you an example, from coming out of R&D to a phase 3 trial will take over 10 years, maybe more. I have had 5 phase 3 trials that finally reported this year and next year in oncology. Those were 5 that took 10 years. That's a long time. And I think we heard earlier that using quantum, it's going to benefit that. So that's where we've been in the past. And we need to understand where we were in the past because at that moment, we're like, well, what can computers do that could help us do this faster and better and actually cure people? So that's where we've been in our past. Very slow technologies, not specific technologies. And with the advent of what's coming, I really think that we can do a lot better there. Are we going to talk about what's happening now or just in the past?
What's happening in the past? I think that we want to talk about the future, yes.
No, present.
The present, yes, sorry. Whoever wants to pick it up.
So the healthcare industry globally produces 30% of the data. Okay, so that's a huge number. So you can see healthcare is a very data-intensive industry. Second is healthcare is number 1 in something. Can you guys guess in which area we're number 1 in healthcare?
Spending, like percent of GDP.
Okay, well, that's a very good guess, and it's really we're number 1 in data breaches.
Yep.
Okay, so because of that, quantum plays really well into what we're doing, right? The other thing about healthcare is the variability of humans itself, right? So just because of the variations of different things and combining it with other variety of different things, it sets itself up for an industry that you could use a lot of these advanced computing technology for. So we're in that space, right? So we're here collecting genomics data now. We have EMR record. We have data interchanges. We are working with such complexity in data complexity in healthcare that I think we need the next generation of computing to make something happen, to solve something critical. So that's where we're at now, and hopefully we get to talk the next steps.
So it's funny you should mention data breaches because, as I was on the last panel, post-quantum cryptography is going to hopefully answer that or solve that, or basically try to make sure that that doesn't happen again. Obviously, in the U.S., HIPAA is still law, right? So any kind of breach has to be it's regulated. It has to be documented and sent to HHS for privacy and security concerns. And there's a criminal penalty, civil penalty, and there could be criminal penalties as well. So, but coming back into the healthcare aspect of it right now, it's a very interesting time. You've got a lot of new technologies that are coming in. The quantum processing is really going to hopefully accelerate the process of actually creating new materials. That's where I like to come in and looking at new biomedical devices as well. And obviously there's going to be testing, clinical trials for that as well. So it's interesting where that's going to go. And I'll leave it out there right now, and we'll talk about that later.
Yeah, okay. So as I want to say, as I explained in the previous session, that the main game in the drug discovery and the drug design is 3 points, in fact. So we need to identify a candidate that's able to solve a large complex problem for a certain disease, cancer or whatever. So these candidates should be promising, accurate, and efficient. Remember, accurate, efficient, and promising. So there can be a possibility nowadays to use AI, for example. It can help you to accelerate the discovery. However, you need precision. And the precision, as I said, it comes from the quantum computing, because it's the only sector that's able to tackle a certain problem inside the atomic level, and the molecular level is the quantum. That's why quantum computing is the main bridge for drug design. Of course, with plus on top of that AI, I would say quantum plus AI for healthcare are the best keys to identify these 3 properties of the candidates for certain problem. And that's why quantum chemistry, quantum computing, for quantum computing is a certain application that's very important to make a bridge for tackling this problem.
Thank you very much. Good background for what we're going to go into now. I have 2 questions that I'm going to consolidate in one, and it has to do with the applications within clinical diagnostics and imaging. The same, I want to use the same pattern, allowing the ladies to speak first.
Thank you. Well, we didn't talk about what's going on right now, and that's an important fact. We have to understand where we came from in the past before AI. Okay, that was the question. Where are we before AI? Where we are today is that AI was able to be used to enhance what we have right now. Okay, so right now we're looking at, in the area of healthcare, we have a lot of problems in healthcare, a lot of problems that need fixing. And it takes a lot of computational power to do that and understanding. So where we are today is AI is now being utilized in the present moment to solve questions that we have in the medical field. However, there are some questions that cannot be answered that way, right? And that's where you would need quantum. So let's talk about AI and the areas where AI has, where AI has really impacted, those areas are actually the same that would be impacted with quantum. So I wanted to bring you from past, present, now future. So for the future, one of the areas that's going to be impacted is in the area of diagnostics, okay? Diagnostics for me is my favorite subject because I know, do you know that in our lifetime right now, that cancer is 90% curable? 90%. Did anybody know that? Yet they're spending the majority of the money at the NIH and everybody else at trying to make a stage 4 drug. What's up with that? So we need to understand the economics of what's happening here, and we should spend more time in the area of diagnostics. Imaging is one of the areas where AI and quantum AI can take an image today, just AI alone, and give you a more precise picture, and it will give you that precise picture in a relatively amount of time. Now you add to that quantum, and you can get real-time information when it comes to looking at what you're looking at. Not only that, but you can take all of your medical scans, your MRI, CT, and this is called multi-omics. And you could actually use the multi-omics and use quantum when it gets too big to digest a huge amount of data, okay? We're not there yet, but we're getting there. We have to fix some of the things now, and there's a place to go. So the first one was in the area of imaging. The second one was?
Clinical.
Yeah, clinical.
Diagnostics and imaging.
Okay, so I talked about diagnostics already. For me, diagnostics is the much more important because in diagnostics, think about it. All the people that you're talking about, oh, let's make a drug, those people are not going to exist in the future after we have quantum. There's not going to be a stage 4 cancer patient. Well, guess what? People that are investing in therapeutics, shame on you. You know that we have AI technology, and in all AI technology can solve diagnostics at stage 1. So at Miami AI Ventures in our fund, I'm only looking at diagnostics that are going to at stage 1 cancer or a disease that's early. Not only can you diagnose, AI and quantum AI can before tell you the probability of you getting that disease. And if you have it in your family, it can go every year and diagnose you along the way and keep you in safe harbor. So there's going to be a lot of changes of what's happening, and I don't think therapeutics is the way that where we should put our money now. We have been doing that for years, and where has it gotten us? Not very far. So today, I think having a diagnostics in the area of any disease, imaging, multi-omics, putting that all together is going to help you determine. You're going to know the chances of you getting cancer. You're going to know the minute you have cancer. Wearables and all that is going to detect all that in the future. In order to have it in real time, and that's the difference between AI and quantum AI, is there's certain areas that have not been impacted with AI because the computational power is too low. And those are the areas that people are starting to look at, where should we focus on? So for the first 5 years, we're going to have a lot of experimentation, but it's not until I think 5 to 10 years is when you're really going to apply the AI to those specific places that are going to be identified that will going to be impacted in the area of healthcare.
If you don't mind, we'll leave the questions at the end because we have a couple more topics, if you don't mind. Is that okay? What's that? Yeah, let's just keep your question for the end, if you don't mind. We'll put you first.
So in terms of diagnostics, right? I mean, we're talking about quantum sensors. I think you were talking about. I think Dr. Haidar talked about that.
Yeah.
So quantum sensors are definitely. You actually talked about it. So quantum sensors are part of the diagnostics, right? And so these are new materials that have to be made and have to be either subcutaneous or somehow have to be able to actually see what's happening in capillaries, right? Veins, things like that. I mean, that's something that is really necessary. I mean, I have a niece, she has a metal alloy in her heart that thankfully has not reacted negatively in her body for like the last 20 plus years. So those are the things that I'm looking at in terms of how do metals react in bodies. One of my research, I was looking at NIH's PubChem. Lactic acid, for example, is extremely. We're talking about cancer. It grabs onto radioactive material very easily, right? So obviously, if lactic acid is used in other mother's milk, right? So these are things that we're trying to prevent, right? For people that are using cancer treatment, especially for women. Those are things that I want to see. I also want to help out as well. So that's another area that I like to hear what's going on right now as well. I mean, there's so much information out there, and it's interesting to see that Libia, Dr. Scheller wants to wants to fund companies that are looking at these, trying to find the answers, right? And I think that's definitely a preventative approach with looking at stage 1 problems as opposed to stage 4 problems.
Mm-hmm.
So this is really, really important for the quality of life, not just for the patient, but as from a cost-benefit standpoint for today's medicine and who's paying for what, right? I mean, it makes much more sense to invest in stage 1 than it is for stage 4. So I really applaud you for that.
Thank you.
This is going to cause me to geek out here. Some of my areas that I like in this space, you guys are very familiar with digital twins, right?
Mm-hmm.
So digital twins are basically AI, simulation, optimization, all mixed into one, right? If you take a look at the, healthcare has a lot of digital twin interests. If you take a look at that space alone, there are so many different types of digital twins. And it could be clinical, it could be process-oriented, it could be device-oriented, right? So let me give you a few examples. You could have a digital twin that could be quantum-enabled, right? Looking at next-generation simulation optimization of the patient's heart. So that's an organ twin. You could have a digital twin that is more of the full human body that contains all of your data, on the vertical stack of what human data is all about, genomics, all the multi-omics, right, that was mentioned here. You can actually put that in there. And there are also what we call system and process twins, and these are more on the operations and administration side of healthcare, where you could also improve that, and that could be enabled from a quantum standpoint. So just that category alone, whoever want to create products there, that would be fantastic. The other area is definitely the sensing side, right? The quantum sensing. I'm already looking at companies, here in the U.S. that are using quantum magnetometers to look at, to actually monitor and connect to single neuronal spark running across your brain and putting that as classical data. So that stuff already exists. It's been 15 years of work in the quantum magnetometer space, and that's the next generation of EEG that we're going to look at, right? Where the technology is not the issue. I think the issue is the adoption cycle of something like that from an FDA, diagnostic, workflow, clinical related stuff, right? So that's another area that I love. Another area that I am really, really passionate about is the intersection of, I know Dr. Haidar talked about quantum chemistry. I'm interested in quantum biology. Okay, so I recently invested in a company out of Stanford, and what they're doing is they created a quantum device that's a quantum electrospectrometer device that is measuring the vibrational signal of all of the different components of a cell. So when you're looking at vibrational signatures, you're getting into the quantum space here, right? I've never heard of anyone creating, that kind of a data set, but if you look at all the molecules, they all have vibrational signals. So
Mhm.
if you look at biology vibrational signals and you look at drug vibrational signals, now maybe there's some pattern matching and some matching stuff that could happen there. So that is the foundation of a quantum biology type of a company. So I'm letting you know that because these are things that I think that are now possible where I thought, I would never see those kind of companies. And then the last one I just want to mention, is, which is more in the therapeutic side, is diagnostic is, somebody from UCLA said, Nardo, have you thought of like a device that's called a quantum nose? Quantum nose. So I got educated that basically when we smell something, right? When we smell something, we're not smelling molecules, we're actually detecting vibrational signals, and that our brain is interpreting that. And so the point that she was having there was, what if you create, those dogs, you have these stories where these dogs are sniffing out cancer and all this. There must be something there. And what if somebody created a device like that is
We
more
have it.
diagnostic? But I just don't know what the science is there
We
yet.
have
But I tell you, it's all quantum. So that area is ripe for disruption.
I think that you have some experience in that from what you're doing. So briefly,
Yeah,
Uh,
I mean, I just want to agree with all of you what you said. Maybe on top of what Nardo said about quantum biology, it's extremely very interesting topic to go for. I think also it could be also as an equal as quantum chemistry, because a lot of people now works only on quantum chemistry, but innovation should be also in quantum biology. However, the only problem nowadays is in the current quantum computers. As you know, these devices, they are prone to noise and they are currently creating a lot of errors. So we have to put a lot of money on the quantum processor units with the hardware engineers in order to tackle the problem using the quantum biology. So I would advise also to make the quantum chemistry and the quantum biology on the same feet. We have to start now in quantum biology. And I'm really very much interested, as I said in the last session, I'm really much interested, whoever have experience in biology or even neurology, I would be very happy to discuss on top of that for quantum biology. So please let me know and don't hesitate to reach me out. Thanks.
thank you much. We're on the last 9 minutes of our panel. This has been very interesting. So I'm going to be asking you to be quick on the next answers. We know where we come from, where we are, and where we're going. I think that there's a lot of promises. The next question has to do with two things: the ethical and practical considerations of using quantum right now, and potentially, I know it's a far-fetched question, timelines.
Yeah, for example, I would give examples regarding the ethics. For example, a lot of patients, they don't prefer to share their data because they want to keep it private. So quantum computer is going to vast a lot of amounts of data. So maybe this data will be kind of misuse them, the quantum computer. This will maybe let the patient not happy with that. So this would feel them like not comfortable to use the quantum computer in this sense. Another thing is that the quantum computer now, as I said, is really releasing a lot of errors. So that's why they need to be convinced by that. To be convinced, they have to work a lot the hardware in the efforts for reducing the errors in the quantum computer. And I think the gap should be reduced more. All the quantum biologists, quantum chemists should be nearby, even the hardware engineers, in order to explain to them, not only the software engineers, to explain to them what is the real problem, because this will help a lot to get a very impact value for using the quantum computer for quantum chemistry and quantum biology. So that's my idea and my point of view.
Thank you.
And I agree with everything you said. I mean, the problem that we have in the United States is that we don't want to share our data. We don't want to share our DNA, but you're doing 23andMe, you're giving your samples to everyone, right? So in addition to what you had mentioned, one of the other things that in the future that we have to think about, people are going to use your data and they're going to monetize that. Is that ethical, right? If you have countries like Ireland and other who have like incredible infrastructures that collect data from every single patient and they give it away freely, they're coming up with incredible technologies much faster. Why? Their data is all together and it's cleaner than what we have in the United States. So the key now is to find out who has those data sets that are cleaner and use them for computational power for the future. So the other question was
Timeline.
the timeline. So I would say for the next 5 years, 0 to 5 years, where we are now is educating people, because right now most people they're afraid of AI. You can't talk to them about quantum AI if they don't know what AI is. And we were sharing earlier, it's important to know where we were, where we are now, right? And what is quantum AI going to do for different areas for us. So education, the first 5 years is going to be experimentation and trying to figure out how we're going to get there. I would say 5 to 10 years, the smart people are going to pick those sectors that are going to have the biggest impact, right? And they're going to go after it. And I think it was 2050. At that point, I think we're all going to be integrated, adopting quantum AI. The problem is education, access to data, and the other one is the people like the FDA who are approving these things. So I think it's going to be a hard climb, because I'm looking at AI right now, and the adoption of AI, as you can see, is quite slow. Yeah, right? So we need more education. So
Very good. We have like 3 more minutes, so if you guys can. And I want to offer this gentleman the opportunity to ask a question.
Sure. So to finish up where things are going to Nardo's point on digital twins, you're going to have, once we have quantum sensors and whatnot embedded, you're going to be able to have forecasting capabilities of a person's health makeup as well, assuming that they allow for, and if there's going to be a baseline based on national trends. There's a company called Komodo Health that tracks data and trends and whatnot. Look them up. But to do that, there's a lot of upfront investment again in trying to create new materials that are going to be able to pass the muster for FDA approval rather quickly, right? Otherwise, it's just going to take another 5 to 10 years, and that's the timeline. So that's where I think, unfortunately, that's where the FDA will put us. Otherwise, unless there's another kind of pandemic moment where they just go right through, the regulators, it's going to take 5 to 10 years.
Yeah.
I'll just answer the timing piece. So from a technology standpoint for healthcare, I think healthcare should implement post-quantum cryptography now. Should implement quantum safe networks now. That needs to happen now, just because we're number 1 in data breach. So we have to counter that. So when we do that, we basically create more of a, I would say, we'll be more comfortable with doing more because we're secure. Okay, that's one thing. The second piece would be quantum sensing, would be the next technology that I'd like to see being brought out there, just because it's the easier technology compared to a quantum computer. And then the last one would be more of start experimenting on the quantum-inspired and quantum and the hybrid classical quantum algorithms.
Thank you very much. I'm going to open up the floor for questions, but this gentleman has the priority.
I just wanted to ask if you guys would be interested in investing for like a natural cancer cure per se, using technologies for analytical purposes.
So when you say natural, do you know that most of the chemotherapy comes from nature? And a lot of people don't know that. One of the biggest breast cancer drugs comes from a sponge from the ocean. So what do you mean by natural?
Or like in an organic form, where
That's an organic form. You need to know the difference between, you need to know how we make our drugs, where they come from. Most of them come, I mean, Taxotere comes from a bark of a tree in the Amazon. All of these were found are natural. So my question is, what do you mean by natural?
Just like in a non-synthetic way, like there's a lot of synthetic medicines or even maybe vitamins, more of a like holistic.
Yeah, the problem with that is scalability because you're extracting from a plant, right? But if you have the chemical structure on it, you can take that chemical structure and if you use it in very concentrated amounts, it could kill you. So your natural product that you're talking about, if you don't get the right dose, just like a chemotherapy or any other, you're going to kill somebody because it's toxic at certain levels. So, and you can use AI to determine the chemistry of it and add something else to it using AI to lessen the side effects. Yeah. Of course. Yeah.
I'm going to continue. I think the lady behind you wanted to ask first. Go ahead.
I'm a data scientist, so I
Mhm.
face these challenges every day. My specialty actually is in quantum biology and post-quantum cryptography.
Oh, wow.
And some energetic signature stuff. My question is specific to you mentioning longevity. So you do focus on diagnostics. So what do you focus on when it comes to longevity? And can you just briefly explain to people what longevity means?
And does anyone of you want to answer? Or?
I do a lot in the longevity field. I'm actually, he says, 105 years old. So, yeah, it's interesting. I love DNA. I said that before. Do you know what happens to your DNA when you haven't had slept, you've had too much, partying in Miami and everything? Your DNA gets hairy. And when your DNA gets hairy, it can't move. It can't fix itself. It can't make things. So longevity for me, medicine, is to make your DNA as stealth as possible so it can operate properly. So with everything that we're having, the best anti-aging that I see is trying to fix that. How do you get rid of the hair? I call them hair. It could be, they're methyl groups, but I call it hair because it can't maneuver. The other area is that when you're under a lot of stress, you can't fix something that that's broken. We all have cancer cells floating around in our system right now. We all do. Not enough sleep, high stress, and all that is going to get you sick. So longevity for me, where we are now and in the future, is prevention, right? And at F3, I have diagnostics that you can't really call them diagnostics. You have to call them, before that is you're going to say the probability of you getting sick. So anything in diagnostics that can prevent can tell you the chances of you getting that sickness. It's here now. We have these kinds of things. We have breathalyzers that can diagnose cancer at stage 1. But my favorite longevity medicine, and a lot of people about this, is stem cells. Everybody's going to go, what? The problem with stem cells, it's not scalable. Where are you going to get it? Miami AI Ventures and Future Fortune Fund has fixed that problem. So everybody's going to have to get their stem cells. Stem cells are not stem cells in this country. We have the real stem cells. So the real way to really help our bodies if something's broken is to get those cells that you had yourself when you were in your mother's wound. That is true longevity medicine.
Yeah. Does anyone of you want to add something, or I will pass on? We have 2 questions.
In companies that are pitching to me, I've seen one company that's doing quantum AI, trying to figure out on the drug discovery side for longevity. There is a company working that.
Nice.
Yep.
Do
You
remember
guys
the name or
want
no?
to choose? See.
It's in the X Prize
Camilo.
program. It's on the X Prize program. You know that.
Comparing quantum computing versus the sensors, I mean, you mentioned the error rate. Is that also a challenge on the sensor technology side? And is like the sort of the ability to improve upon that similar or different challenges?
I think it's more on the computing side, but because these are also working with qubits. qubits, right? So quantum effects and things like that. It's and less in lesser numbers. So I would say it's that big of an issue because there are already a lot of sensors that are, for example, the quantum magnetometers. I've seen them in smaller form factor now. But there are so many different sensors out there, like quantum gravimeters, and those gravimeters that measures gravity, they look like maybe half of that couch, right? So that's a huge sensor. You can't carry that in your wrist, right? So there's a lot of miniaturization challenges, and even though these are only a few qubits, you still need to protect them from a lot of the interference like EMIs and things like that.
Yeah, maybe I add also on top of Nardo, very interesting about quantum sensing. In terms of quantum computing, like photonic device, ion trap, or semiconductor, atomic, I think the main error, if you will just acknowledge, I want to share it for you, the main error is coming from the 2-qubit gates, in fact, which is the entanglement gate between 2 qubits. This is the main error comes from. And that's why all the hardware engineers now, they are putting a lot of efforts on tackling this problem. For 1 qubit gate, you have no problem because the fidelity is 99.99%. But for the 2 qubit gate, a lot of problems. And that's why it's making challenging. And I agree with Nardo also, the scalability is also a problem because the more you scale the number of qubits, the more also you need to enlarge the width of your circuit design when you apply it in a certain algorithm. So that's one of the main sources now. And as you know now, we are the NISQ device, noisy intermediate scale quantum computing device. So that's why they are prone to noise, we call them, because of the 2-qubit gates. So we are not yet in the fault-tolerant quantum computer. Once we are there, we are going to start with the drug discovery, application, and design, and simulation also, which is going to be, I hope, very, very soon.
Thank you very much to this panel. Amazing opinions. I would like you guys to give a round of applause. And I know there's more questions, but Camilo, you have them all for yourselves after this. So please go ahead and ask the questions later. Thank you very much.
A picture.
Of course.
Thank you.